Hello everyone. This view that you currently see is the data pipeline view within the product Stream Analytics. As you see on the top here, we have two engines, Storm and Spark, and the number next to it denotes the total number of pipelines that have been built in the respective engines. Right now, Spark has been selected, and it shows a quick view of the Spark cluster on which this entire setup is running on. Right below, we see all these different tiles. Every tile represents a Spark job and the state of that job, whether it's active or stopped. I'll be moving to the pipeline integration view. This is one of those capabilities of the platform that Anand just described, where we could interconnect multiple subsystems or pipelines, jobs connected in, or rather created in various different technologies. So for example, right here on the canvas, what we see is one use case that has been solved by interconnecting 4 different jobs. 3 of those jobs have been created in Spark, while 1 output job has been created in Storm. Similarly, another use case of network anomaly detection, which has been created by interconnecting 2 jobs, one written in Storm, the other written in Spark. Let me walk you through both these use cases. The first one is a movie lens use case that I'll be talking about, this particular one. The first job written in Spark is the input pipeline job. This job takes in the user input. So imagine a screen like Netflix where the user is shown a bunch of movies. The user rates a particular movie. That rating acts as an input to the system. The system takes the user ratings, and along with that, it also brings in the historical information about that user's previous browsing patterns, previous ratings that the user had given. So all of that enriched data from the input pipeline flows into these 2 other pipelines, ALS and PPMS. Both these pipelines are having recommendation engines. The ALS pipeline having the recommendation engine ALS, while PPMS pipeline having the recommendation PPMS. Both these pipelines independently generate a set of recommendations for the user based on the input and the enriched data that it receives from the input pipeline. These recommendations are then streamed to the final output pipeline that's written in Storm, and this pipeline pushes out the recommendations of both those algorithms to the end user. I'll move to the demo screen for this particular use case. Right here, we see a bunch of different movies. I shall rate Jungle Book as 5-star. That's been one of my favorite classics since childhood. The moment I rated the movie as 5, it triggered an event. The event has now streamed to the system. The system is taking in that event, the historical information about the user. All that enriched information has now been pushed to the 2 algorithm pipelines, PPMF and ALS. And as we saw in a short while, we got the recommendations from both those pipelines right here. So this is a classic example of A/B testing, where as a data scientist, let's say I want to compare the results of 2 competing algorithms to figure out what's more relevant and what's appropriate for the particular use case. So in this example, I could now side by side do a comparison of the recommendation results of 2 different algorithms and figure out what's the best one for the particular use case. Let's assume that I select PPMF as my choice of algorithm, and I say, okay, PPMF looks more relevant, and hence I want to now make sure that PPMF is the algorithm that's going to be providing recommendations from now on, and hence all traffic should only go to PPMF and not ALS. And now in order to achieve that functionality, I go back to the Stream Analytics UI. The path that connects the input pipeline to the ALS pipeline, I select that path and I simply delete it. So now as you see on the screen, the current configuration is the input pipeline only sends the data, including the enriched information, to the PPMF pipeline alone and not to the ALS pipeline. I click on update. Now that the changes have taken effect, I go back to the demo screen. I refresh the screen. I rate Jungle Book. And now the results that will show up show the recommendations from PPMF alone, and no recommendations from ALS have come forth. This is because the input to the ALS has been cut off. So as you saw, without any downtime, at runtime, dynamically we could control the flow of traffic from one subsystem to the other. Having said that, the system also supports controlling the flow through filtering criteria. So it's not necessary that I need to control the flow either as a binary, either all data goes in or not. I can actually control the flow using criteria where I can right click on the connector path and say, send all the data for region west to an algorithm A and send all the data from region east to algorithm B. So those kind of options and configurations are also possible, which are dynamic, happens at runtime without any restart required. So that was use case one. The second use case was the network anomaly detection. Let me open up the pipeline for the network anomaly detection right here. So this is the pipeline view of the network anomaly detection. We are using the streaming k-means algorithm in order to do the clustering, in order to detect anomaly. Two different sources are being fed into the k-means algorithm. Both these sources are reading data from Kafka. One of the sources is the prediction source. We have used network data as one of the examples for this use case. So the prediction source is actually the network traffic that gets generated on a Wi-Fi router, for instance. That data is sent to the streaming k-means algorithm. The k-means algorithm will inspect that particular data. It will figure out what cluster does that particular data belong to and plot the data into that cluster. On the screen, what we see here is a view of how the streaming k-means algorithm has been configured. So if we see here, the prediction stream component has been the prediction source, and this particular algorithm also supports online real-time learning as well. So while the prediction source is used to check whether there is anomaly or not, the training source feeds into the algorithm in order to have the algorithm keep recalibrating itself, keep recalculating its own centers in real time. And that's the purpose of the training source. In the variable type, we see all these different variables, continuous, categorical, the 10 clusters, and so forth. So all of this can be configured right here on the UI. Now, once the anomaly prediction happens, if it is detected as true, it raises an alert. And if it's not, it's sent to the feedback loop to be sent back to the training source. Now, let's quickly run through an example of this. Right here, we have a summary of the anomaly job that's running on a Spark cluster. So it gives us a view of how many batches it has completed so far. Are there any batches in the waiting stage? How many tasks, stages, and jobs these batches have manifested as? One of the tabs on the top is the cluster details. I'll click on that, and now I shall start the data generator to push the prediction data. Now, as the data starts coming in, the k-means is now going to act on that data, start creating the clusters. We see the clusters now appearing on the UI, and we also see one of the points is an anomaly. The large clusters denote the centers of the cluster, and the small circles denote the incoming data and how far they are from the center. In this case, this guy was an anomaly because it is way too far from the cluster itself. And as an anomaly happened, we also saw an alert that got triggered, and on the top we see an alert count of 1. As more and more data keeps coming in, more anomalies occur and the alert count keeps increasing. So this is another example where we had interconnected multiple systems. The initial source system was a storm system which was used for doing pre-processing like data quality checks, data integrity checks, and once any data that passes through those checks, it directed the flow into another subsystem which was written in Spark that we just saw, which executes the streaming k-means algorithm on top of that. So with this, I conclude my demo here.